Hello, students. Today I will discuss anthropometrics, which is a very important part of ergonomics. Now, I mentioned before when I discussed ergonomics, introduction to ergonomics, the basics. I mentioned that the human body dimensions, which means the human body measurements, are very important to consider when you design something. Well, this is the anthropometrics part. When you talk about human body measurements, this in ergonomics is called anthropometrics. So today we will focus on this part of ergonomics, which deals with the measurements of the human body and how this can be applied in design. Now, anthropometrics originates from the Greek, again, from the Greek language, which means measurement of man, okay? Now, ergonomics cannot exist without anthropometric data, anthropometrics. You cannot design something that is ergonomically sound without having taken into consideration anthropometric data, which is the measurement of the human body, of every detail of the human body. So, anthropometrics deals with what? With body shape and size. Not also with the body shape and size, of course, because you will have different measurements. If your size changes and the shape changes, the measurements will change. Now, you probably know that people come in all kinds of sizes and shapes. You will see short people, you will see high people, you will see fat, thin people, you will see people from different age groups like children or adults. They are also have different body dimensions. So anything you design, you must take the body size into consideration. Now, sometimes you need the entire body. Sometimes you need just parts of the body. We will discuss this today in our lecture in more detail. Sometimes you need just the hand or the head or the feet, you know? So, anthropometrics provides designers with a good reference guide of human form in regards to what body dimensions and also the mobility of limbs. What are the limbs? For example, my arms are called limbs. My legs are called limbs. So the mobility. Like, for example, how much can I pick up my hand? How much can I stretch it backwards? My head, for example, how much can you move it sideways? Okay. Obviously, you cannot move your head 360 degrees. There is a limit. So the limit of the mobility of the limbs, okay? Because the human body is not staying in a static position. As we said before, the human body is in constant movement. So we need to know the mobility of the limbs, of the different parts. How much can I move my limbs? How much can I stretch my body? Because this is related to design. If I design something and I consider the human body as a static, non-moving object, your design will not be very correct. You have to consider that the human body is moving, okay? So when you use this product again, okay, you're not using it like this only. You're using it while moving. So the measurements of this design, the measurements will have changes. You have to consider the measurements while the human body is using in movement. Now, maybe it's comfortable like this. This, for example, size of this hole, if I put my finger here, maybe it's comfortable if I don't move. But what happens if I move? Maybe I will need extra space so that my finger has the possibility to move. So you need to understand when you're designing something, you need to understand exactly how the human body moves using this design to perform a task. How exactly, for example, how do I move my fingers? Exactly how do I move whatever other body part? So this is not an easy thing to determine. But this is how good design results. Comfortable design for the human use. And you need to always aim at that. So here we can see in the pictures, you have, for example, this image. It shows the human body. Here we have male and here we have a female, and from the front and from the side view. And as you can see, a lot of measurements. Every body part is measured. Now, this is a human body in static position, non-moving. And here, as I said, in anthropometric data, in ergonomics, you can find also information about moving body parts. Like, for example, this leg, how much can you put it up? This foot, for example, what is the degree? What is the maximum degree you can move it at an angle? Okay. The arms, the same thing. The head, okay. How much can you move it down and up and sideways? Every detail you can find in anthropometric data reference books. Now, these reference books, you can find a lot of types. Sometimes you can find them focused, like, for example, anthropometric data for product design. Anthropometric data for example, focused on fashion designers. Anthropometric data focused on interior design, on architecture. So, because this data is so huge, you know, sometimes they focus them according to discipline. And then you can find, of course, data for all kinds of body dimensions, all kinds of age groups, and so on and so on. So these things, when you need them, now we are dealing in this course mainly with the basics. So we will not go into the great detail of actually using this data in great detail, only in a basic level. To understand it, we need to understand, okay, everything about it and how to select the correct data. We will talk about this today. How to select, because I have so many numbers, how to select for my design. This is what's important. Now, finding the information, finding the data is more easy than selecting it, knowing how to select it correctly. So pay attention to this. Now, how did they collect all this data about the human body? Well, they actually measured human bodies, millions maybe of human bodies. They were measured, and then the data calculated and placed in drawings and tables, and we will see examples in a minute. So data is collected from a large number of people, and then it's categorized. It's put into categories in tables, okay? That includes specific groups of people. Like, for example, men, women. They cannot put them both in one group because by nature, they have some differences in body measurements. Men are usually bigger in size, have different shape of the body even than women. So they have to categorize them separately in different groups. Also for children, you know, children cannot be put in the same group like adults. Even children, boys and girls, have different measurements. People of different ages also have different measurements. Like if you compare an old person with a young person, very old person, like 80 years old with a 20-year-old, the body will look different, have different measurements. So when they put this data together, the numbers, they put them in separate tables. This is how you will find them in books if you need them in the future. And you will need that. Any project you do without considering the measurements of the human body will not be successful. Because in ergonomics, we said you're designing for whom? For people, for people. So if you ignore the body shape and sizes of people, then obviously this, whatever you're designing, will not be fitting the needs of your target group of people. So, as you can see here, you can see some strange looking instruments that were used to measure every body part. So, now in anthropometrics, very important, when you're designing something, you need to consider these 4 points. Decide who you are designing for. So your target group of people. The age is very important. What age group? From 2. Okay, this is one type. Then what exactly are the characteristics of your target group of people? Like, as I mentioned before, sometimes you are trying to design something for like people with specific disabilities. So this is a target group of people. I'm designing only for this. And sometimes you're trying to cover as many people as possible for your design. Like if you're designing this pen, for example, this is for as many people as possible. So you will see this exactly pen, everybody in Jordan using it, okay? And outside of Jordan, the same. So when the designer designed it, he had to take into consideration the maximum amount of people that would fit size-wise to be able to use this pen. So it has to fit into my hand, and it has to fit into your hand, and it has to fit into millions of people's hands comfortably. But sometimes, as I said, you're designing for a specific target group of people, which does not include so many people, like with special disabilities, as I said. Okay, so decide also what you are designing. What is it that you're designing? So if I'm designing this mobile, it's very different than if I'm designing this, for example, or if I'm designing the car outside, or if I'm designing this, or anything. Products you will see in thousands of products you see every day, you come in contact with. So you need to understand, what is it that you're designing? What is it? Not only what is its name, like this is called a scissor. No, this is not enough. What is special about this, that product that you're trying to design? What body parts will be used? What characteristics should it have? You need to imagine the whole scenario. What is this going to be used for? What is its function? What are the tasks you will perform with them? All of this is related to what you are designing. What is a scissor? Ask yourself, what is this? What is it used for? What is its function? How it's going to be used? Okay? So this is deciding what you are designing. You also need to decide which body measurements are relevant for what you are designing. Which body measurements? Do you need the head? Do you need the hands? Do you need the only one finger? Do you need the leg? Do you need the feet? Which body measurements? Because in anthropometrics, as I said, they measure the whole body and they include all the data. But you must select, I need this and I need that for my design. I don't need all of the data to use it all the time. It depends on what you are designing. So this is related to which body measurements are relevant. And then the last point, you need to decide whether, if you are designing for the average person, the average sized person, this is after you're deciding the target group of people. Like, for example, I'm designing only for women, something specific. Then inside this category of the female category, I need to decide, okay, am I designing for the average female, or am I designing for the extreme? Like, for example, the very big and tall women or the short ones. Now, what if you're designing for example, covering adult males and females together? Well, then you also need to decide for the average or for the extremes. And you need to take into consideration the differences in the body sizes of both categories. So should I select the largest males and the smallest females, or the average male plus the average female, and make some kind of a mix in my design and decide? Well, this is crucial because there are so many possibilities. And when you select the number, the numbers you need, the data, anthropometric data, you need to be clear about what data to select. We will see in a bit some examples, okay, of tables and how this is done. So you need to decide which anthropometric data to select to fit best your target group that you selected. You're always focusing on the target group. You don't select the target group and then you start designing and forget the target group. Unbelievably, it did happen in this class before. Like students telling me, I'm designing for the adult, male and female, from, let's say, 18 to 50 years old, for example. And then their design turns out for children. Now, what is happening here? What is happening? You must remember, when you select the target group, to stick to it, to stick to its needs, measurement needs, body needs, everything related to the body, okay? Look at these few examples here. So, for example, the headphones, okay? If you're designing this, okay, then you probably need to know anthropometric data related to the ear, okay, to the ear. Exactly the shape, the size, the details, because how can you make this design correct to basically hold in your ear and be comfortable and be safe if you don't understand the structure of the ear and its measurements? If you're designing a mouse, okay, you will be using it with your hand, okay? So you need to understand everything about the hand. How do you hold the mouse? How do you move the mouse? What happens with your fingers and with your touching points? Where are the touching points? Where are the pressure points? Where are the angles that may happen during movements? Everything you must analyze. Everything you must consider before you make a new design. Because as we said before, if you design something, it should solve a problem. You're not just designing for fun. So solve a problem, then your design will be, in a way, useful for this world. if you're designing a chair, for example, depends on what type of chair. There are so many types. Each chair has its own requirements. We will not go into it, but this is, for example, an office chair. It has certain measurement requirements that's different than, for example, your chair used at home for the kitchen where you sit and eat, or the sofa that you sit on at home and relax and watch TV. This is an office chair. Its function is different than a sofa, than a relaxation chair. This is used for work, and it's used in a very specific way, okay? The movement while the body is sitting on it, it's moving in a specific way. It has different requirements to make the body comfortable during work than a relaxation chair at home. It has a different function, okay? These things I'm talking about are very important, because later when you start your projects, you need to think in this way so that you end up with a good project. If you just look at things in a shallow way, not deeply, but just in a shallow way, your project will be shallow and poor. It will not have the information required for you to receive a good mark. So be careful, think in detail about everything. So for example, again, in this office chair, you know, what body parts measurements do you need for it? So you have, for example, these measurements here. Which ones of these do you need to consider to design a suitable, comfortable chair that meets its users' needs and also functions in a correct way, depending on the tasks, what you do with it during work. Now, there is something in anthropometrics called percentiles, okay? We will discuss what is percentiles, because this is the most important thing for you to understand, to be able to select the correct measurements. So, we already discussed that people come in all kinds of sizes, But in anthropometrics, now you cannot design for, you need categories. You need simplification to be able to design, because if you're designing for, let's say, 5 million people, you cannot consider every person's differences in size. No, there are categories, main categories. In anthropometrics, they categorize people into the 5th percentile, the 50th percentile, or the 95th percentile. Now, the 95th sometimes varies. In tables, in anthropometric data, you will sometimes see 98 or 97.5, like variations, but it is still close to this number, okay? So these 3 categories, people's measurements are put into these 3 categories to simplify things. Now, what does this mean? What are these meaning of what is 5th percentile? It means the smallest of the people, the smallest of this group of people. Like, for example, if you're looking only at females, the smallest of the females, or the smallest of the male, these 2 measurements will be different, but each group of people is categorized into these 3 types. If you look at children measurements, for example, you will again find 5th, 50th, 95th percentile. So the smallest will be the 5th, with the smallest body measurements. The 50th is the average, The 95th is the largest people, the biggest from this group that you're looking at. Now, So why do they put 5%, for example, for the smallest people? Because they, like, after a lot of measurements and, you know, thinking and analyzing, they decided that usually in a population around, it's not exact number, but it's around 5% are usually, you will see extremely small people from a category. They are usually not exceeding 5% of the population. Now, all of this here in the middle is the average population, okay? It's the average. So from, this is the medium, not too small, not too big. It's in between the average population, which takes the 50th percentile. Now, another 5% of the population is considered to be out of range, extremely big. Like the extremely small, we have extremely big people from a certain category. Now, we will discuss this a little bit more in detail later, but in many designs, designers select the 95th percentile for 95th percentile numbers for their design. Now, what is the 95th? If I select the 95th percentile, what does it mean? It means all of these. So the average people and the small people will easily fit into my design. Now, I said sometimes you will see here not 95, you will see 97 or 98 percentile. For example, this means that they left only 3 or 2% for the very large people. So when I select the 98th percentile of the population, it means that my design will be suitable for 98% of the people. So almost everybody will be, as a measurement of the body, will fit and use my design successfully and comfortably. Very important for you to understand the meaning, okay? If I design for the 5th percentile, if I select the numbers related to the 5th percentile, it means I'm only designing for this target, this group of the whatever group of people I'm designing, only the smallest. So sometimes in designs, you have to select the 5th percentile to design for these, to focus your design on these. Sometimes the 95th, which will include all this. Sometimes the 5th of the very largest, but usually in most designs, the 95th or 96th or 98th, whatever variation of number here exists, is selected for design. This is most of the time. You're trying most of the time with your designs to cover as many people as possible. Sometimes you have only specific types of people you cover, then you select other numbers related. Sometimes you select the average, the 50th percentile of the population measurement to design for them. Now, the design for the extremes, like the extremely small or the extremely large, okay? Okay. This, for example, can happen if you design a door, okay, where you come in and go out. So a door has to fit the largest people. You have to try to fit not the average. You need to fit the extremes, the very large people. Because imagine if you're high, if you're tall, and you try to go into a door which is short, you have to do your head like this and go in. It's not acceptable. Now, a big door can accommodate small people and large people. So you need to focus on the large people. What is their size? So that you design the door also with sufficient clearance, okay, for tall people and short people to be able to go in and go out. A door is usually a public It's used by the public. So many people go in, go out, go in, go out. So you need to fit their body sizes. So you select the maximum height of the population and you design for this number, for these measurements. Now, when do you design for the minimum, like the small people of the population? For example, distance of a control button. For example, a control button, a button, you know, you have to, a device and you have to press a button. And for example, the reach for it. Like if I'm a short person and I cannot reach it, okay, it's a problem. It's a problem. Now, if I was a tall person, I can reach it easily. But what about the short people? What about the small-sized people? So you need to focus to design whatever you're designing, again, here for the short people so that they can also reach. The tall people, they can reach it by default. Design for adjustable range. There is also this type of measurements where you design sometimes, depending on what you're designing, for adjustable range. So my design can move, can be adjusted. Like, for example, the office chair. Let me go back to it. For example, this office chair. Usually this can be made higher or lower. This is adjustable range. So for example, if I have short legs, I can adjust, you know, the chair go up or down according to what fits me, my size. If you were designing the seats of the car, also the car seats, very important to fit, to be able to fit with the smallest females and the largest males. So you take the extreme number. So this range from to the smallest females to the largest males, all of them have to fit into this car seat. Because imagine if you're a small female and you buy a car and, oh, I cannot reach the steering wheel because the seat is fixed. It cannot move. So you need to design for the adjustable range. So if I'm short, I will move the seat forwards. If you're a tall person, you will move the seat of the car backwards to fit your legs. So a car intention of it as a design is to be used by as many people as possible. So you need to consider the very small to the very large, and you need to take these numbers into consideration when you design an adjustable seat, for example. So one limit of the seat will be to fit the 5th percentile, the smallest, and the other limit will be to fit the largest people. Sometimes also we said that you're designing for the average. What's the average? The 50th percentile. Now, this is not a very accurate number, because if you're designing for the average, you take the average number, it's the easiest to take, to find, I mean, you know, and to apply, but it's not very accurate, because if you design for the average, it means the small people will not be very comfortable using it, and the very big people will not be comfortable using it. So average, sometimes in some designs is okay. It depends on what you are designing. Again, what is it that you're designing? Then you can decide, should I design for the extremes, for adjustable range, for the average? You need to make this decision after you know what is it you're designing, its characteristics, everything about it. And of course, you need to have an idea who is your target group of people. So where are these 4 points we discussed? These you need to have decided, okay, before you end up in the last point where you have to decide these. We already discussed this actually. So for example, here we have an airplane seat for the airplane. Now, this seat, should it be designed for the 5th percentile, the small people, or the 95th percentile, for example, to fit as many people as possible, including the bigger people, the larger people. Imagine if the airplane seat is too small, and you are a fat person, a big person, a tall and fat. It will be a problem. And this seat, the airplane seat, is used by the public. So today, a very small person will sit on it. Tomorrow, a very large person will sit on it. Thousands of people sit on this chair. So it has to be designed to fit as many as possible. The same with the car, seat. The car seat, on the other hand, must also be, what did we say? With an adjustable range, so that the small people can reach the dashboard, and also the large people can reach it and be comfortable. So these are things from our daily lives that you can relate to and understand what are percentiles using them. Look around you, the objects that you're using in your daily life, and decide, if you were the designer, which of these percentiles will be suitable to use and why? In anthropometric data, as we said, when you open, for example, books about anthropometrics, you will find always static body dimensions and dynamic body dimensions. Now, static means these are examples of static body dimensions. It also here has angles. This is related to the dynamic body dimension, like what are the angles that you can pick up your hand or move your head. So you will find static and dynamic data here. And as you can see, all these numbers are like, what is, for example, the size from here to here? What is from here to here? What is everything, every detail you will find with a number, okay? Sometimes you will find 3 numbers together. Like, for example, this is, let me see. For example, yes, from here to here. So the head, from here to here, how much is it? Okay, you will find this number. Sometimes you will find 3 numbers. What are the 3 numbers mean? It's usually the first is the 5th percentile, then the 50th, then the 95th. So, for example, this is a male, okay? And this is a head measurement for a male. Now, this number, as I said, sometimes you will find 3 numbers. So the first one will be the smallest male size head, then the average, then the big, okay? So 5, 50, 95th. Sometimes you see only 1 number because this somewhere, it's mentioned, for example, that these measurements are for the, let's say, the average or the 5th or the 95th percentile. Here also, again, a lot of body measurements, and even, as you can see here, for people with handicaps and during movement, like, for example, this person here, what if this person put the body forwards, okay? Look here, the body forwards, and try to reach something. So I'm trying to reach. We said it's very important to make things reachable. So what about if a person is in a wheelchair? The reach will be different than if you don't have the handicap. If you're walking on your legs, it's different than if you're stuck into a wheelchair. Here, you're stuck inside a chair, inside a car. You cannot stand up, move around the way you like. You're stuck in it. You have to be able to reach while sitting comfortably on the chair and safely. The driving has to be safe, so you cannot reach and move around the way you like. So everything has to be designed using measurements to make this possible, the human body to reach everything comfortably and safely. So again, everything is related to what is it you're designing and for whom are you designing? This is, for example, if you're designing for handicapped people with certain physical limitation. So you need to take this into consideration in your design. How much can this person inside this chair reach the hand up, for example? How much space does the person need to move around to the house with a wheelchair? So if you're an interior designer, you need to consider that sometimes people are handicapped and they need space. They need space, you know, to move around. It's not only about this object and the human, it's about also the space around the environment, as we said. The dynamic body dimensions, as we already said, the person while in movement. So in a lot of designs, designers actually draw simplified, abstract versions of the person that uses the correct proportion measurements of the target group of people, like from here to here, for example, the height. So I'm designing for male only, okay? So I have to use the male body dimensions. And for whom am I designing? For the 95th percentile of men. So I have to take their measurements from here to here, the hand measurements, everything, draw my drawing in the correct scale, then draw my design, whatever I'm designing. Let's say I'm designing a kitchen, for example, okay? And put my object, whatever, with the correct scaled size inside my correctly scaled design and see what happens during movement. Do you see these points here? They're at the joint areas. Remember, the human body can move because of the joint. So, for example, if I don't have joint here, I cannot move my finger. If I don't have a joint here, I cannot move my finger. The joint here, okay, can move my hand. Can I move it sideways? Well, a little bit, but not too much. So if I move it this way, what angle? If I move it that way, well, it's not possible, okay? So how does the joint function? And when you do the drawing, for example, you put points at the joint areas, and then you can move the person, you know, sitting, standing, moving, and you decide, is this measurement of my design, is it correct or not correct? Do I need to make something bigger, smaller, more clearance, whatever, okay? So if the person is kneeling on the floor, is it comfortable to open this or not? These type of drawings, as I said, designers all the time draw when they design something to show how their thinking process, how they used the data, anthropometric data, how they considered ergonomics. So how did you end up with your new improved design solution? When in future you will make bigger projects like your graduation project, you will have to explain, why did you design it in this way? Why did you use these measurements? From where? How? So you need to have correct images, correct sketches, correct. Every decision you make must be based on ergonomics, on correct use of anthropometric data that will influence the size of your design, the measurements of your design. And you need to have this in drawings and tables to prove to the jury that, yes, I made the correct design decision. If you ignore this part, your design will be lacking severely. Again, measurement examples, the body in movement, okay? What are the maximum angle, okay? Like I can move my elbow, look at this, for example. I can move it at a bigger angle like this, but when I move it that way, it's kind of not too much. So from this line here, what is this angle? Or what is this angle, okay? The head, how much can you move it? This is the neutral 0, okay, line. Then from here to here, how much? How much can you move it forwards, the head? From here to here, how much can you move your head backwards? And here you can see with dotted line, it is drawn also, the limit. So this is the limit. The limit from here to here, from here to here, the limit of the angle. You need to know that depending on, of course, what you are designing. Sometimes you need to know how the human body moves, or part of the human body moves. We already talked a lot about this, okay? So here are examples, and usually you will find in books, when you look in ergonomic books, anthropometric data books, you will find a drawing, okay? And then you will have here a letter, and then you will find a table with the information. So what is angle A? What is angle B? Here again, what is angle A? This angle. What is angle B? So you have a table where you have all the information written. This is, for example, for men. Then you have for women or for other groups of people. We already discussed about this a lot of times, also the natural and unnatural movements, that when the human body moves, you need to consider when it's moving, whatever you're designing, it has to fit the natural movements of the human body. You don't want the human, for example, let's say if I'm designing for my hand to twist, you know, in unnatural ways, because this will create pain and health issues. And this is against ergonomics. You must design always to consider the human health is number one, and the human safety. So always design considering the natural movements. So you need to change the shape of your design to fit that movements. And you need to know what are these movements? Where are the touching points between me and this object? Where are the touching points? And then what movements will I make with this, okay? To fit correctly, to keep my hand in a natural state while using it, to reduce possibility of pain and health issues. So this is example of anthropometric data table, as we said. So for example, we have here the human, and we have, for example, from here to here, and letters. For example, this is E. From here, from this joint area, it's always the joint areas that are used, okay? From joint to, for example, the limit down. So from this joint to this, F. So if I want to know what is this here, I look here. So F is the here, and it doesn't matter what it's called, these namings, they're very complicated. You just focus on the letter. So from here to here, I want to know what is this measurement. Here I look, okay, this is F. Now we see here several measurements. We see here what? 5th percentile, 50th, and 95th. And then we see, let me see, this is for the male and this is for the female. So the measurements for the man is here, okay, the blue, and the female is here. If you notice, okay, like if I take the 50%, the 5th percentile, the small men, they will have this size for number F. If I take the small females, they will be even smaller than the male, okay? This is their number. If I take the 95th percentile, the larger, okay, the male will have this number, the female, this number. Now, I have to decide as a designer, should I use these numbers? Should I use this number only, or only this number, or both of them? Or should I use this number, or this number, which is the average? So if I want this distance here for a design that I'm doing, I need to know which of these to use. The 5th, the average, or the 95th, which is for all of this fit, for most of the people. And which, the male or the female or both. So, and this goes for each body part. Like if you have the shoulder width, okay, from here to here. This is letter C. So here, Letter C, again, we have the same. We have to decide, should I use the 5th, the 50th, or the 95th, and which of these two, or both, for this category, okay? Which is male and female. Okay, so this is a nice and simple example, but usually in drawings, you'll find a lot more numbers. So like this, for example, where did we see? Like this, okay? So you find so many numbers, okay? Because they measured every detail of the human body. So you need to know which of these numbers should I use. If you notice here, even though they're very small, as I said, there are 3 numbers here. For this measurement, there are 3. For this, there are 3. For this, there are 3. So it's the this, the 5th, the 50th, and the 95th. So they put both numbers. So you will see a lot of numbers, but they shouldn't be confusing. Also, you need to be careful. Sometimes they put the numbers in centimeter. Sometimes they put them in millimeter. Sometimes they put them in inches. So if you see inch, you have to, and you want to use centimeter in your design, you need to be careful not to use this number. You have to transfer it to centimeter or millimeter, the metric units, okay? So be careful what numbers you see written. Like here, for example, what is this number? 12 what? Centimeter or millimeter or inch? So when you look at these, they will always tell you it's in inches or centimeter or millimeter. So you need to be careful. You will also find in anthropometric data books, manuals, you know, even for other details. Like for example, here we have the height. Okay, you're designing a table, and you have, for example, for precision work or light work or heavy work. So if you're doing heavy work, or you need to be doing precision work, like for example, drawing. So the height of the table must be different. Okay, so regarding the human, here we have A and B and C. So A, for example, this is the standing height of the human, okay? And here we have eye height, elbow height. So how much should it be? Depending on what you're designing. Here, for example, you have a chair and a table and the measurements, okay? How the human measurements with the design measurements. Here, for example, for when you're sitting, what is the reach? So we have a normal reach, okay, which is comfortable, and we have a maximum reach, which this is the maximum length of the hand of the target group of people that I'm designing for. So if you have to design something that uses the maximum reach, you need to take into consideration also, is the design used for a long time? Because if a person has to use his hand for like this for a long time, okay, it's available as a number, but is it practical? Because you will get tired. It's more normal to design within a comfortable reach, not a maximum. So you have to consider the whole scenario of the what task will be performed here. Like if I have to type on my keyboard like this comfortably, I can type a long time. If I have to use the maximum and type over there, I will get tired very quickly. So what is practical here? What is the you need to imagine the person, the human, using your product, whatever you're designing, as a movie in your head. You have to play it out as a movie. Imagine all the movements happening, all the possible scenarios, everything before you design something. Okay, so this was the lecture about anthropometric data, which we said ergonomics cannot exist without this data, because ergonomics deals with the human body. Now, it deals with many parts of the human body, even with the psychology we said before. But imagine you don't know the measurements of the target group of people you're designing for. So your design can never be correct. So ergonomics must always use anthropometric data. This is inevitable part of ergonomics. So any design you design, you must use anthropometric data. You need to find the correct data and design whatever you're designing to fit with this data and the human population you're designing for. Okay, thank you for watching and see you soon in the other lecture.